Hello, I'm making another video on the calculus end of topic test, except this time we're doing question 3E, which is the is an optimization question, and it's one of those nice comprehensive excellence questions. So if you do all the excellent stuff, you get a nice T beside it. If you get it nice and correct, yeah. And I've lost my script for this one, but what happens today at school? I made a script with the help of George and Sam. Sam has submitted another very tricky question that we need to answer after we've answered our original question, which is the question that we're going to be doing now, which is 3E. So the question 3E. It's about a shotgun case, and we want to know what the maximum volume of that shotgun case will be. So let's draw up that shotgun case. It's going to be one of these long thingies. See, I wouldn't know. I don't have a shotgun case. There we go. And then we're going to, so we know that it's a shotgun case, we're going to write shotgun case on it. Okay. So the question is, a shotgun case must be cuboid in shape with a length that is 9 times that of the width. So we'll write that down. A shotgun case must be cuboid in shape. With a length that is 9. So, my day's been very good. That is 9 times the width. So I'm writing down the question because I'm extremely unorganised, as I seem to have lost my script. The sum of the width, height and length is 2 meters. What will the maximum value of the case be? Okay, so the sum of... meters, what will the maximum volume of the case? Done, we've got the question. Now I need to have a sip of my chalky milk. Now we're nice and ready to do some maths. Right, cool. Let's get started on this question. Right. So, the question we've got here, we're trying to look for the maximum volume of this shotgun case. So, volume can be measured in litres, or I don't know, cubic meters. Yeah, no, so with this one we'll be using cubic meters to measure the volume of this shotgun case. So this shotgun case is, I would say it is a shotgun case. So anyway, it must be cuboid in shape as I've drawn, and with a length that is 9 times the width. So 9 times the width. Let's label our variables. So we want width to be 9. No, we want the width is already 9. So we want let width be W, and then we want length be L, and then we want the height to be H. Cool. Now, since we've labelled our variables, as you can see here, we can now write all over the shotgun case diagram, the picture that we've drawn here. So we're going to say that this is the width here. So we know the width is the width. Nice. And then we know this is going to be the length. So the length is going to be 9W. 9 lots of W. Now, what we can do with this is that we've established that length is 9W. So let's write down here so that we know for bullet point. Length equals 9W. Cool. We're happy with that. I'm happy with that. Let's go. Let's move on. So here's another part of the question that we've got. I might get a highlighter. Okay. So we'll highlight what we've covered so far. So we want the most important stuff is that here we want this length is, and then we want, now another part we've got is the sum of the width, length and height is going to be 2 meters. So we're going to know, we will know that L plus width, which is W, plus H equals 2. Now we know that this equals 2 because length is L is length, W is width, H is height, and the sum of them, which is length plus width plus height, equals 2 because the question says so. We'll highlight that because we've got that now. Hate highlighters, are trash. There we go. Nice. And that will be okay, cool. Now we want to know what will be the maximum volume of this case. So here we go. Continue. We're going to continue doing our maths. Right, so we've got length equals 9W, and we've got the sum of the length, width, and height. Cool, so let's move on. Now we're going to create another equation, because we know length equals 9W, we can substitute L. So that would equal 9W plus W plus H equals 2, which would equal 10W plus H equals 2. There we go. Right, that's where we are so far. And now what we're going to do is from here what we're going to end up with is we're going to end up with the volume, and to get the volume we times the width, length and the height. So we want to end up with we would like length times width times height equals the volume, or how math people like to call it, the Vmax volume, maximum volume, because I've said maximum volume here, so they're like, no, you need to have Vmax instead. Well, I just put volume because I'm lazy. Anyway, well, now we've got that. From the information we've been given here, we can actually create an expression to represent this. Or no, an equation to represent this. So, the volume of the case equals, so volume of case equals L times W times H. So let's substitute in L, 9W, the width, and then the height, which will give us 9W squared times H. See? Nice and sexy. Nice and good maths. We're doing good maths, yep. So hopefully you understand what I'm doing. So with this one here, I've just timed 9W by W, 9W by H, and that will give us 9W squared times H. Now, since we've done this, now we want to know what equation for H could be. So, see how we've got 10W plus H. Now, that equals 2. So we want to derive a equation to represent, or to solve for H. We want to make this equal h. We want to make h the subject. So let's make h the subject. So when we do that, that's going to be h equals 2 take away 10w. Cool. Now that we've got that, to make things even more complicated, we can put our new known value of h, or our known equation for h, and substitute it into here. So we'll have 9w squared lots of 2 take away 10w in brackets. So that will look like this. So substitute right, and that would look like this. See? Understand that? Yeah? I know I do, because it's my maths. Well, no, it's actually George's more, because George actually made this a lot easier for both me to understand and also for people who might be not as strong at maths to understand. Thank you very much, George. This is all your work. Anyway, now that we've got that, we can expand this so to make it a bit easier for us, because I don't really want to differentiate that. I'm just giving things away. I want to make this bigger, so let's make it nice and good. Simplify. Cool. So let's expand. So that would equal v equals 18w squared take away 90w cubed. Oh, please be like that. Right, cool. Yeah, that should be right. Now what we're going to do is we're going to differentiate this, because now it's a function, because v is like the y, and then this is the equation. So what we can do now is that we can get prime of v, which would equal, if we differentiate 2 and 18, 36 w 90 just be 270 w squared. Yep, so that'll be what that is. And now that we've got this nice easy thing, we could actually factor out w's right now. Yeah, so the reason why I'm going to factor out w, this will make sense eventually. We want to make this function equal 0, so we want 0 to be equal to 36w take away 270w squared. Now, what we're going to see, this is kind of like it's not really a quadratic at all. It's more of a thing that we want to be able to easily solve. So we'll just factor out w, and that's really easy. So that means w36 take away 270w, and that looks nice and good. Cool. Now, after we've done this, you can use our calculator. Finally, we get to use our calculator, and we can use the solver. Favorite father calculator. So we can do, let's say 0. Bread biscuit. 0 equals x lots of 36 take away 270x, which simplifies to, hold on, I did a winner. I can't afford to do winners right now. Come on, just work. Okay, cool. So we'll end up with this number here. Now, what could that be? In fraction form, that would just 2/15. Yeah, 2/15. So we've got 2/15 right now that we know that the W equals 2/15. So we've just solved for W. So this equals, yeah. So we've worked out what W is. So using solver, we solved for W, which is the width. So W now equals 2/15 because we made it. Now, we want to find our length as well as our height. So over here, we're going to find our length. So we've got the width, which equals 2/15. Please be 2/15. I can't afford for it to not be 2/15. And then we've got a length which is 9 times 2/15. 9 lots of 2 divided by 15, please. And that would be 1.2. I usually like to use fractions, but with 1.2, it's a nice easy number to just write as a 1.2. Otherwise, I could just write it as 1/15. Now we're going to get the height. Now, to work out the height, we know that L plus W plus H equals 2. So we know what length is. So that's 1.2 plus 2/15 plus H equals 2. I'm just going to put this into the solver, and that will give us a nice number. Our number that we want. So that will be 1.2 plus 2/15, and then we'll have plus X, which is H, but the graphics calculator doesn't offer any other variables, which I don't really expect it to. Then we'll solve that. Then we get 2/3. 2/3. So we've got 2/3 now, and that means that the height equals 2/3 because we proved it using solver. Find H. So H equals 2/3. 2/3. Now, H equals 2/3. Now that we've done this, we've found our width, length, and height. Yes, I'm very happy. We get to do the volume, so we get to do this. We would like to have length times, we want to do that now. But this is good because we've got all these values. Now all we have to do is substitute our values of the length into there, the width into there, and the height width into there. And that'll give us our maximum volume. So here we go. 2/15, 0.1333 times 1.2 times 0.0067 meters. We're doing it in meters because that's the correct unit, and we want to end up with cubic meters, which is I'm a winner at maths. I can't do anything else. I can't do this kind of maths in my head. Times 1.2 times 0. We'll just do 2/3. Doesn't make much difference. 0.106. Yep, so that would equal 0.1066 cubic meters. Not cubic meters. There we go. Now that's our final answer. There's nothing further we can do with this question, really at all. Maybe we could have signposted more, but otherwise this question is complete, and that is our answer. If you might be concerned as to why I used 4 decimal places, well, it doesn't really. The question hasn't asked us to provide a certain amount of decimal places or a certain amount of significant figures, and they haven't given us any numbers apart from 2, which is one significant figure, and it's a whole number. It's not got any decimals hanging off of it. This one is 0.1066 cubic meters. And I'm not going to round that to one significant figure or one decimal place, 0.1 cubic meters, because if you change cubic meters to litres, it'll be like Well, this one, for instance, would be 106.6 litres, and I mean, we're not using litres, but you know, if we did, yeah. Anyway, yes. So I thought that question was quite good. If you do actually have any questions about how I did that, or if you want to give me any constructive criticism as to whether I made some really fatal errors, which I could have, because I did not go off of... I went off script again because I'm a dickhead. Yeah. But, oh, hold on. We've got a question submitted by Sam, and it's a very good question. Now we need to do some working for this. So, why did the dog run fast? You might be wondering. And I think that the dog ran fast because it drank petrol, and I'm pretty sure that's the correct answer, because I've come across this question a lot in maths, and I'm talking shit, but you know, this is a very mathsy question, probably level 3, maybe university maths even. So why did the dog run fast, you may ask? No, I'm asking you, why did the dog run fast? So why did the dog run fast? Right. Now this question is quite difficult. So they ever mistake. See, this is winter music. If you don't listen to this every day, you're not a winner. Okay, so the dog ran fast because it drank petrol. So if you would you like to see, I'll show you my working for this question, because you might be confused as to where to start. So so the question is, why did the dog run fast? Now you need a bit of you need a large amount of contextual knowledge, because this is a question from Sam which he made up himself, and that was the answer that he gave us. So that must be the answer. That's as far as we can go with this question. Well, we could use proof by contradiction, but we could say that we could come up with an idea that the dog does not run fast, but if he still drinks petrol, he still doesn't run fast. And then we can't really contradict that, because it would end up being true, and that would make us look really dumb if we did proof by contradiction in an actual math question and we actually contradicted it, or thought we contradicted it. Anyway, thank you very much for watching this. Goodbye.